Hello, friends. If you have learned Spark but still feel confused about what actually happens when you run a Spark job, then this video is for you. Many people can write Spark code, but they struggle in interviews when asked questions like, what happens internally when you run a Spark job? Or what is the role of the driver? Or how are stages and tasks created? In this video, I'm not going to teach Spark syntax, but I'm going to teach you the mental model of Spark, how Spark thinks, how Spark plans, how Spark executes. By the end of this video, you should be able to visualize Spark execution in your head and confidently explain Spark end to end in interviews. Let's start with the most important question first. Why Spark even exists? To understand Spark, we need to go back in time to Hadoop. MapReduce. MapReduce was designed to solve one big problem. How to process huge amount of data across multiple machines, and it did that job well. But MapReduce had a very serious limitation. It was disk heavy. Every time a map phase completed, the output was written to disk. Every time a reduce phase started, it read data from disk. Now imagine a real-time pipeline. Filter data, aggregate, join, transform, and then aggregate again. So in MapReduce, this means multiple jobs, and every job reads from disk and writes back to disk. Disk input output is slow, and this made jobs painfully slow. MapReduce also struggled with modern workloads like machine learning, where the same data needs to be processed repeatedly. Spark was created to fire this exact problem. The core idea of Spark is very simple. Keep data in memory whenever possible, execute multiple transformations together, avoid unnecessary disk writes. That's the foundation of Spark. Now let's understand how Spark is structured internally. The first thing to understand is this. Spark is not a database, and Spark is not a storage system. Spark is a distributed computation engine. At a high level, Spark has three main components. First is the driver. So the driver is where your Spark application starts. Think of it as the brain of the Spark application. Second is the cluster manager. This can be Yarn, Kubernetes, or Spark standalone. Its only job is to allocate resources like CPU and memory. Third are the executors. Executors are worker processes that actually run the computation on the data. A very important point to remember is your Spark code runs on the driver. Your data processing runs on the executors. This separation is critical for understanding Spark execution. Let's now walk through what actually happens when you submit a Spark job. Everything starts on the driver. When you run your Spark code, the driver reads your code and builds a logical execution plan. At this stage, Spark is not executing anything, it's only planning. Once the plan is ready, the driver asks the cluster manager for resources. The cluster manager launches executors on the worker nodes. Now comes the very important concept, tasks. Executors do not receive your entire program, they receive tasks, which are the smallest unit of work in Spark. Each task processes exactly one partition of data. Also, remember this clearly, executors never talk to each other. All coordination happens through the driver. This single point of coordination is the key to Spark execution model. Now we reach the heart of Spark's execution model, DAGs, stages, and tasks. Spark uses something called lazy evaluation. This means transformations like filter, select, and join are not executed immediately. Instead, Spark records this transformation and builds a directed acyclic graph or DAG. The DAG represents what needs to be done, not how it will run it. Spark then analyzes this DAG and looks for places where data needs to be shuffled across the cluster. Every time a shuffle is required, Spark creates a stage boundary. So remember this rule. Shuffle boundaries define stages. Within each stage, Spark creates tasks. So each task processes one partition of data. That's why you will often hear this in line in the interview. Number of tasks equals number of partitions. Now, why data frames are faster than RDDs? This slide answers one of the most important and common Spark interview questions. Why are data frames faster than RDDs? RDDs are very low level abstraction. When you write RDD code, Spark treats your logic as a black box. Spark does not know what your function is doing internally. Data frames are different. They are schema aware. Spark knows the structure of the data and the operation being performed. Because of this, Spark can use the Catalyst optimizer to rewrite queries and the Tungsten engine to optimize memory and CPU usage. Data frames also use columnar storage and vectorized execution. That's why in almost all real world applications, data frames and Spark SQL are preferred over RDDs. Now, why PySpark is slower? Another very popular interview question is why PySpark is slower than Scala Spark. Spark itself is written in Scala and runs on the JVM. When you use PySpark, your Python code runs on the driver not on the executors. The actual execution still happens in the JVM. This means data has to move between Python and the JVM, which introduces serialization and communication overhead. Python UDFs are specially expensive because they break the Spark's optimization pipeline. So the key takeaway is this: Spark is fast, PySpark is slower than Python JVM communication, not because Spark is inefficient. Now let's quickly bust some of the common Spark myths. More executors do not automatically mean better performance. Poor partitioning can actually slow your job done. Caching does not always help. It only helps when data is reused. PySpark does not run Python code directly on executors. Everything runs on the JVM. Shuffles are not unavoidable. Many are caused by inefficient joins. And finally, data frames do not hide execution. You can always inspect the plan using explain. Knowing these points shows deep Spark understanding in interview. So let's wrap everything up with one simple mental model. You write transformations, Spark builds a DAG, Shuffles split the DAG into stages, partition creates tasks, tasks run in parallel on executors, the driver coordinates everything, and execution happens on the JVM. If you understand this flow, Spark will never feel confusion again. If this video helped you, like and subscribe, and I'll see you in the next deep dive. Thank you.